All right, so in 2.6, we're going to be talking about a couple of different special functions, that's what they call them. We'll be doing the piecewise defined function in this video, and then an absolute value function in the video of part B. So piecewise defined function, it's literally taking this function and splitting it up into a bunch of different pieces. So there are these separate pieces of different graphs that you put all together on one graph. So you can see, like, we've got an example right here, example 1. You've got these two different graphs. Now, originally, last chapter, I could give you just y equals x minus 1, or I could give you y equals -1, and you'd be able to plot either one of those. But these are these separately defined functions that have different domains. So normally, you'd be able to plug any x value into the function wherever you want, but the way that these work is you only plug x values that are less than or equal to 3 into this function. You only plug x values that are greater than 3 into this function. So you'll end up kind of having these, like I said, two separate pieces, almost like you copy and pasted them from their own graphs into one joint graph. All right, so really important piece that you want to keep in mind. Each one of these pieces has to stay within its domain. So picture it as like being on its own property. Each piece must live in its own property. So the very first thing we want to do is put up kind of a fence in between. So keep all your work kind of over on the right-hand side here, and then we'll do all of our scratch work over here so we get the graph. So like I said, each piece has got to live on its own property. So let's put up a fence between the two properties. So x equals 3 is where the dividing line occurs. So we are going to go over 1, 2, 3, and we're going to put up a fence there. Okay, so wherever the dividing lines are, we are going to put up a fence between those two properties. All right, so there's now a fence, there's a dividing line between the property where x minus 1 lives for values that are less than 3, and then the property where -1 lives, which are for x values that are greater than 3. All right, so I'm going to keep everything color-coded, and I think that'll kind of help you guys to keep everything organized. So if you do have multicolors, that would be a great use of them right now. So this is graph number 1 right here, and then this is graph number 2 right here. Okay, so first one, second one. So this is graph number 1's domain right here. So graph number 1 gets to take up like this whole area right here, and then there's a fence, and then this is graph number 2's property over here. Okay, so it's really important to make sure you know how it divides and that you know that these graphs can't cross over the line. Okay, so then next thing we're going to do, so we've got this fence down the middle here, so we're going to start with graph number 1 over on the left hand side here. So graph number 1, we'll get all our work in. So very first thing we're going to do is we're going to plug in the point that would be right here, because we want to see where this graph would be right on this line. So since 3 is the dividing line, that's the very first x value that we're going to plug in. So that's every time, no matter what, you always start with this x value that they give you. So we are going to plug in 3. So this is saying we're going into the function and we're going to plug in 3. So that's first going into this one. So the graph is x minus 1. So when we plug in the 3, it becomes 3 minus 1. And of course, that gives us 2. So that turns into an ordered pair. So that's the very first ordered pair that we're going to plot is 3, 2. All right, now you know from graphing different types of lines that you can't just have one line, or I'm sorry, you can't just have one point in order to plot the line. We need another point. So you can plug in anything else you want over here, any x value. You could plug in 2, 1, 0, -1, any other x value that you want to plug in. So let's say that we plug in 0. You cannot plug in 4, 5, 6, etc., because that's on graph 2's property, and we can't cross the fence over into the other guy's property. Okay, so we plug in 0. So this, we got 0 minus 1. And that leaves us with -1s. That's another ordered pair that we're going to plot. So we have 0, -1. All right, so we're going to plot that in a second, but I also want to walk through graph number 2's information here. So graph number 2. So because 3 is where our fence is, you always want to start by plugging the 3 in. Okay, so we're going to plug the 3 in. So f of 3 means we're going to use this function right here, and we're going to plug in the 3. Now this is kind of a unique function because this tells us that the function is equal to -1. There's no x, which means that the function value doesn't change when you change the x value. Here, the function value obviously changes when you change the x value. But what this means is no matter what you plug in, we're going to end up getting a -1. So if I plug in 3, I get -1. If I plug in anything else on this side of the dividing line, we would also get -1. So f of, now remember you can plug in anything on this side of the fence, but you can't plug in anything on this side of the fence. So you could plug in 4, 5, 6, anything you wanted. So this time let's just go with the very next value, we'll plug in 4. So remember, same idea, there's nowhere to even plug in an x. So the fact that this is just a number means no matter what we plug in, we're gonna get a -1. Oops, I forgot to write down our ordered pair. So this ordered pair would be 3, -1. This ordered pair would be 4, -1. Okay, so let's plot the points. We've got our ordered pairs, which means we have enough to draw the lines. There's one more important detail that we need to be aware of, and that is who actually owns the fence. So this, if we look here, we've got less than or equal to 3. So this guy has the equal sign, so he owns the fence. That means that he can sit on the fence. So that's what we're gonna do. So this ordered pair right here, this is right on the fence. That's 3, 2. So we're gonna go up 2. So what that means is that property number 1 actually owns the fence. So it's allowed to sit on the fence there. So that's the first point. Second point is at 0, -1. So that would be this point right here. Okay, so we start with this point. Remember, you're not going over the fence. You can have anything you want in this property, and that arrow just extends to show that the graph just keeps on going all the way to the left, because from this fence onward is property number 1. Okay, so now that whole sitting on the fence business, let's look at the next one. This is just x is greater than 3, which means the fence itself is not actually part of this guy's property. Okay, so when we go to plot this point, 3, -1, what we do is we put an open circle right there, and what that shows us is that you can get right up to that line, but the actual fence itself is not part of that guy's property. So think of it as like, you know, he can't sit on the fence, it's not his property, but this guy could sit on the fence if he wanted to. So we can get right up close to it. So what we do is we mark that with an open circle to show that the fence is not actually his property, but he can get as close to it as he wants to. Okay, and the next point is 4, -1. So that would be this point right here. And then we just extend off to the right, just a straight line. So that if you plugged in 5, you'd get -1. If you plugged in 6, you'd get -1. So that just turns into a horizontal line. So keep that pattern in mind. Anytime that this is just a number, you should just have a horizontal line. If it has an x, then there should be some slope to it. It would be a diagonal line. So that's our graph. The very last detail we're going to worry about with these is the domain and range. Okay, so don't forget about that. Identify the domain and range. So our domain, remember domain is all the possible x values. Okay, so what I want you to think about doing with this one is kind of scan the graph from left to right and make sure all the x values get covered. If all the x values get covered, then you say that it's all reals. So remember this little symbol, the double block R, stands for all reals. And what that just means is every x value gets covered. So the arrow to the left, the arrow to the right, you go here and then this x value leaves off, but this graph picks up right where it left off. So every x value gets covered. For y's, that's the range. Same thing, I want you to picture tracing up and down. So as we go down, this arrow goes down forever. So we keep going, we go up, and then it stops dead right here. None of these y values up above this point get counted. So if we see the highest possible point is a value of 2, so what we say is that y can be anything less than or equal to 2. We include the or equal to because the 2 actually is part of our range, and then it goes down forever from there. So 2 is the highest possible value, and then it just goes down from there. So that would be our domain and range. That's the last thing you guys need to include. All right, example 2. Let's set up the exact same thing. This time we have 3 pieces, so it's going to be just slightly more complicated. So set up your area over here. Okay, we're going to set up our fences to make sure that all of the pieces stay within their own property lines. So the first fence goes at 0. That divides these 2 pieces, one from the next. So our fence goes right here. We're just going to put a dotted line right down this line. I tried to go like off of it a little bit, I guess, so you could see that it's there, because otherwise it just looks like the y-axis. And then the next fence will be at x equals 2. because that's the next value that divides this up. So we've got 1 and then 2. So here's your other fence. Okay, so this is like 3 different areas, 3 different properties being divided up. So first we've got, this is number 1. So this is where property number 1 goes. It extends like this. This middle one, this is property number 2. So that guy just goes in the middle right here, just this little piece of property. And then our last one, number 3, is this section over here. Okay, so make sure that each piece is staying within its own property and that we're only plugging in the values of x that we're allowed to plug in. Okay, so starting with property number 1, let's do that whole piece. So you start with the fence, where you always start with the value of the fence. So this one, its fence is at 0. So we always start by plugging in the 0. So f of 0 can get plugged in here. So we have x over 3 is our function. So that means we plug in the 0 for x, and then 0 over 3, of course, gives us 0. So that ordered pair would be 0, 0. Okay, and the next you can plug in anything else that you want as long as it's within this guy's property. So we can't plug in 1, 2, 3, etc. But we can plug in -1, -2, -3. So the one I'm going to pick -3 just because I have to divide whatever I plug in by 3, and that way it'll come out even instead of coming out as a fraction or a decimal. So if I plug in -3 for x and I divide it by 3, that comes out to a -1. Okay, so my second ordered pair would be -3, -1. And 2 ordered pairs is plenty. That's enough to actually graph your line and see what it's going to look like. Okay, number 2. This is the first one we've seen. Oops, that one's supposed to be green. This is the first one that we've seen that the property is bounded on both sides. So with that one, you have to make sure that you're plugging in both fences. And since there are 2 fences, that's your 2 points, and you don't have to worry about picking another random one to plug in. So first we plug in the first fence, which is 0. So it gets plugged into this middle one right here, 2x minus 6. So 2, plug in 0, minus 6. This is 0 minus 6, which gives us -6. And then, like I said, since this property line has another fence on it, that's the other value that you have to plug in. So the fence is at 2. Disordered pair. This ordered pair would be 0, -6. So now we'll plug in the 2 into this function. So 2 times 2 minus 6. So 2 times 2 is 4, minus 6 is -2. So the other ordered pair that goes right on the other fence would be 2, -2. All right, and then third property is property number 3. So we always start by plugging in the value along the fence, and that value is 2. So first we're going to plug in 2, and this one is just a number, just like we had with example 1. So remember what that number means is no matter what you plug in for x, you're just always going to get this as the value. So if we plugged in a 2, it automatically means we get 1. So that ordered pair is 2, 1. And then we can plug anything else in that we want along this property line. So we could plug in 3, we could plug in 4. Let's say we plug in 4. And again, what this function tells me is the function value is equal to 1 no matter what I plug in. So this comes out as 1. So my next ordered pair is 4, 1. And I just noticed this says G, not F, so I apologize. These should all be G's. These should be G's, just to match the same letter that I used in the original problem. So G, there we go. All right, so let's take these ordered pairs and plot them. Remember, the last detail that we need to worry about is whether or not they can actually sit on the fence, whether or not they own the fence. So let's see. If we look at the red property right here, x is less than or equal to 0, which means the red property owns the fence. Okay, so the point that gets plotted on the fence gets to be a closed circle because this property is the one that actually owns the fence. Whenever it has the equal sign, that's what that means. And then the other point is -3, -1. Okay, so that would be like right there. So here's our other point. And then we just connect the dots, arrow off to the side. Remember, the furthest piece on the left always gets an arrow to show that it keeps going. Next, the green property. So let's see, 0, the 0 fence is not owned by this property right here. So the 0, -6 is not allowed to be a closed circle. So this has to be an open circle because the green property does not own that fence because it doesn't have the equal sign on the 0. It does, however, have the equal sign on the 2. So that means that the green property owns this fence. So the point on this fence is allowed to be closed in because they own it. So this point right here. 2, -2 would be this point right here, and this one gets to be closed because the green property owns that fence. So then connect the dots. Looks like that. And now our last property, the blue property. So the first point right here is 2, 1. Now let's see if they own the fence. They do not, because they do not have the equal sign. So 2, 1 has to be an open circle. So there's the 1. So 2, 1 is an open circle because the blue property does not own that fence. And the next property is 4, 1. So that's just this point right here. Notice you only have to worry about the open or closed circles if you're actually on the fence. This one is just a normal dot. This one is just a normal dot because that's inside of their property. We know that they own that. So if it's part of their owned property, it gets to be a closed circle. It's only if it's technically on someone else's property, like this one and this one, that it has to be an open circle. All right, so that is what our second graph looks like. The last thing that we have to do is the domain and range. So I will sneak that in right here. Most of the time for these, the domain is all reals, unless for some reason it skips over any x values. But if you're tracing the x values, all these ones to the left get covered, and then this one leaves off, but it picks right back up. And then it goes over here. This one leaves off, but then this one picks right back up. So no x values actually get skipped over. So the domain is all reals. And then the range, we want to see which ones of our y values get hit. So let's see. So this looks like the lowest possible y value right here, but if you were to look at this piece, this arrow just keeps going down and down and down. And if I were to keep graphing it, it would keep going down forever. So there's no lowest possible point because the arrow keeps going down. If we go up, let's see. So there's a gap in the y values here, but these ones pick it up. So these y values all get covered. And there actually is a little gap between y values right here. So there's nothing covered between 0 and 1. So the y values start at 0 and then they go down forever. So we would say y can be anything less than or equal to 0. And then there's this little gap in y values. Nothing gets covered between 0 and 1, and then 1 gets covered, but only 1, nothing above it, nothing below it. So we would just use an equal sign to say that y can be anything less than or equal to 0. So this y value starts at 0 and then it goes down forever according to the arrow. Or the only other y value that gets hit is 1. So this is just a consistent y value of 1. So that would be your domain and range for this one. Okay, so that is it for our first special function.